It's 7 o'clock on the dot. It's go time. Planetarium Live. We're back. Episode 8. Gosh, it's been a while. A couple months. Lots of crazy things have happened, but that's okay. We're going to be doing a lot of really cool stuff today. And here I am. I've got a bit of a different camera now, which is better. It's working out well. I have a new space. We moved over the last couple months, so that was a little bit crazy. But we're here in the new place, ready to do some new science, some new astronomy. And I've got a lot of crazy things on the go in terms of new stuff, new content. Aside from just streaming, I want to keep doing these Planetarium Live streams again and again and again, because they're a lot of fun, and I love being able to interact with all of our viewers, whatever we end up getting, which is just really fun to talk to actual people. Up on the Astro in Action YouTube channel, we've got Astro Views, which is interviews with really cool space people. I just posted the first one on Monday, and this week I'm recording 3 more. So we've got lots of really great people coming up. You check that out on the Astro in Action YouTube channel. Started a space club because that just seems kind of cool. $20 a year to get a membership with Astro in Action, but also with SLU, which is they have telescopes in the Canary Islands and in Chile that you can use anytime. Like literally, I could go online right now, look through one of those telescopes and take a picture of something that it's looking at. Or I can schedule maybe for tomorrow night my own observing session because I want to see the Whirlpool galaxy or something really cool. So that's kind of neat. And that is on the webpage, astronomyinaction.com/space club. You can't miss it. And there's one more surprise coming down the pipeline, but I'm not going to talk about that one just yet. So we have one person watching. That's wonderful. Thank you for watching, whoever you are. Please say hello in the chat. Even if it's just me talking to you, that'd be kind of fun. So let's do it. But I'm going to go back. We're going to work our way to what's up in the sky right now, because that's I haven't been streaming for a really long time. And so I thought it'd be kind of nice to see what do we have in our sky tonight. Now this is going to be the sky, of course, for Southern Ontario, where I live, but we're still going to see what's going on because most of this stuff you can see across the entire country, the entire continent of North America. So we're going to go get a little bit darker and see what's up in the sky tonight, and then we're going to crack a new program that I haven't used, well, that I've used a lot of, but you haven't seen before. So it's really cool. We're gonna have fun doing that. All right, so we're at about 22:57. Okay, that's a little late. It's 11 o'clock. We'll go back till just after it gets dark. There we go. Ah, yes, we did just pass the solstice a couple weeks back, so we're getting we're not getting a lot of stars until a little bit later. So let's go to 10 o'clock. Well, 10:30 maybe. Yeah, so it'll be dark by 10:30. We can see some of the brighter stars out there. Spica, a bright blue star, part of the constellation Virgo. There's Virgo. Right in there. One of the things that's up high this time of year, there's a couple of really bright stars. We've got Arcturus way up high. Arcturus is a bright red star. Oh, it's actually a double star. I didn't even know that. But it's a bright red star that's really easy to spot. I think it's the 4th or 5th brightest star in the night sky. And if you see it, even in the city, you can see a bright red star, in this case toward the southwest. But the real reason we want to look up in the sky tonight is that we've got a couple of really prominent friends. Oh, there's Antares as well. To the south, Antares is part of the constellation of Scorpius, and it kind of does look like a scorpion. We only get to see Scorpius and Sagittarius, for that matter, in the summertime here in Canada and Southern Ontario, mostly because they're southern constellations. If you live in the southern hemisphere, you can see them a lot more often. But Sagittarius, the Archer, it's supposed to be an archer. It doesn't look like that, if you use your imagination, right? But the Archer looks a lot more like a teapot. And so you can see the Sagittarius teapot if you have dark skies toward the south. And Antares is often called the rival of Mars because it is a bright red star. Really easy to spot, really red. And then you've got a lot of other cool things around here. But the interesting part about seeing Antares and the two constellations, Sagittarius and Scorpius, is that they're right along the center of the Milky Way. You can kind of see the haze of the Milky Way here. The core of the Milky Way is right in here, where there's that super massive black hole hanging out, hiding in there. So it's a good time of year if you want to see a lot of stars, because even if you have a pair of binoculars, you can go and take a really close look at the Milky Way and look at all the stuff that's there. I think this is the Trifid Nebula. I think that's the Eagle Nebula up here. Right, so there's lots of really cool things to look at along the core of the galaxy. There's also a couple of globular clusters as well. But I'm not going to spend too much time in Stellarium because I really want to show you Space Engine. Oh, hey, our first chatter. Malcolm and Amelia say hi. Hi, Malcolm. Hi, Amelia. I'm so glad you guys could tune in. Just wait. I'm so excited for you guys to see the next bit of software that we have. But you know what's cool to look at tonight is some planets. This is the best year in decades to look at Saturn and Jupiter. You can see them toward the, what direction are we at? East, southeast. Sorry for scrolling back and forth. Southeast, they rise late, 10:30 now, and they're working their way up along with the moon, which is pretty full. I think, how full is it? Let's see, 95% full. So the moon's pretty bright. Really, when the moon's really bright, the only thing that's good to look at in the sky is the moon, right? The moon's the brightest. It's easier to see. Saturn and Jupiter, though, going to be pretty close together. They're really easy to spot at this time of year, so you can go outside if you do feel like staying up late. The good news is, though, is that as time goes on, we can go forward a few days in time. So tomorrow, next day, the next day, the next day. What you're noticing is that Saturn and Jupiter are actually rising earlier and earlier. So this is in the 21st of this month. If we go into August, there goes the moon again. Goodbye, moon. If we go into, let's say, August 15th, now you're actually seeing Saturn and Jupiter together rising at about, well, just the visible just after sunset. And so that's at that's 8:30 right now. We get to 9 o'clock, 9:30. Now, if you look due south, you'll be able to see Saturn and Jupiter, two bright dots. And if you haven't heard this before, the best way to find planets in the night sky is to look for the things that aren't twinkling. The planets, they don't twinkle, okay? And if you have binoculars, one of the cool things you can do, if we, oops, wrong button. If we center on Jupiter, is you can use binoculars to actually see the four big moons. Callisto, Ganymede, Europa, and I guess Io is behind the planet right now. Or at least this is not today, so right, this is in August still. But you can see those moons actually move around the planet from night to night, so that's always a good one to look at. One other thing to look at in the night sky at this time of year, if we look kind of overhead, again, you know what, I'm just going to go back to today. It's bright right now. The sun hasn't set yet. Oh, too far. See, this is the problem with time controls, is I'm really never good at getting just enough speed to see it properly. Okay, here we go. So this is tonight. Vega, Deneb, and Altair form this big thing that we call the summer triangle. Big summer triangle. Because it looks like a big triangle up in the sky, but these three stars are part of their own constellations. We can see Deneb is part of Cygnus, this big cross-looking thing. It's often called the Northern Cross, but it's known more as a swan, Cygnus the swan. Vega is part of Lyra the harp, which usually you can see as, you'll see this kind of triangle here, and then the diamond of Lyra. And then Altair, the third bright star we're going to get rid of, is part of Aquila the eagle, which, let's be honest, doesn't look like an eagle. If you see it in the sky, all you're going to really see is the bright star Altair. But the cool thing is that it lines up with the Milky Way, so you can find the Milky Way pretty easily. And there you go. And if you do feel like staying up, whoa, spinning around, we can always see the Big Dipper. Whoop. We always see the Big Dipper here and all the stars in the Big Dipper, the double star Alcor and Mizar here, and the second in the handle. Those two stars actually orbit each other, which is kind of neat. And of course, we can always find the North Star by looking along the Big Dipper. Last two stars point to Polaris. There it is. And look at that. It's north. Who knew? Okay. So that's it for Stellarium. I just wanted to show you what was up in the sky. I'm not sure if you can actually rewind the Twitch stream. It's actually my first time streaming on Twitch, which is a big video game platform. But I like it just because it's really easy just to get started and go on it. So let's go. let's go to me. I want to say hi again. For now that you've joined, I can say hello to my friends who are here. Please tell me in the chat what you want to see as we go along, because this program I'm about to show you is something that I have been hooked on for the past 6 weeks. It is unbelievable. It's called Space Engine, and I'm actually going to use it to make Planetarium content. But for today, we're going to take a look up close. And let me introduce you to Space Engine. So this is the Earth, as you can see, but Space Engine is literally a simulation of the universe. We can fly around, we can orbit the Earth pretty easily and see that we have day and night. We got a lot of really cool stuff around. There's the sun. It's pretty bright, pretty hot, but we can make a nice eclipse. There we go. And so Space Engine is going to let us fly around. We can literally go to anything that we see in the sky, right? Anything at all. And we can look for anything at all. So, you know, since Saturn and Jupiter are really prominent, let's just back up a little bit till we see the moon. Where's our moon? Here, moon. Am I in front? Oh, there it is. You can see it moving. Okay, so we're going to center it, and we're going to go travel to the moon. One thing to keep an eye on is up here in the top left corner. We get a lot of information about things, including how far we are from it, and that's going to help me because that way I don't fly right past it. So we're going to slow down a little bit as we get closer to the moon. There it is. Whoa, easy. See what I mean? There we go. And we'll center on the moon. It says we're following Earth. There we go. Oops. So the controls are still a little weird for me, but there we go. We can now see the moon, and you can see the Earth down in the background. So look at this. We can actually go and take a closer look at the moon, and here's the cool thing. We're going to go land on the moon. We can actually do that. It's a 10-second little time thing, but we're going to go fly right here in this lovely, puffy, dusty part of the moon. All right. And here we are. This is the surface of the moon. And look at that. We can see a galaxy off in the distance. That's Andromeda. We can see the Milky Way. We can fly up a little bit and take a closer look. If we go a bit faster, we can see some big craters here. The moon's a nice place to visit, but we have the power to go so much further. So over the next, I guess, 45 minutes or so, we're just going to explore some things. Space Engine is this really interesting simulator where it takes everything that's real. So the moon, the Earth, the sun, all the planets, all the stars, even galaxies like Andromeda, like that guy right there. And it puts them into the simulator. But it also adds a bunch of other things called procedurally generated objects. Procedurally generated, which means they're not real things. So a good example of this is that we can go and visit any one of these stars in the night sky. Any one of them. And some of them will have planets. Some of them will have moons. Some of those planets will have moons. Some of them will have black holes flying around them. But they're not based on real objects. It's something that the program has created. So what I'm going to do as we go along is I'm going to try and tell you that most of the thing, or when we look at something in particular, I'll be sure to tell you if it's real or if it's not. Okay? So let's go visit something. And you know what a good one I think is? Let's go see the North Star. So we can actually search everything here. Polaris. There it is. All right, and now we're going to go to the North Star. Look at this. Now as we fly faster and faster, we're actually traveling among stars. Some of them are closer to Earth and the sun, and so they move past us as we go to them. Polaris is pretty far away. We're closing in on it. If you look at the top corner, we're about 100 light years away still. So we're moving faster than the speed of light, which is really crazy about this. And we're going to go all the way to Polaris. It tells us some things about Polaris, the North Star. It's 4.5 times as heavy as the sun. It's actually a binary star as well. So these are two stars that actually orbit each other. This is Polaris, a white supergiant star, 4.5 times as heavy as the sun. That's what we see as the North Star. So let's center it there. And we can fly around a little bit. And we can see that other star there. The second star, Polaris, much smaller, a main sequence star, but that's 1.39 times the mass of the sun. It might be an even more interesting place to visit. One of the cool things we can do is we can actually take a look at this system. So here's what's really interesting. Here's what's really interesting. So there's actually 3 stars in this system. Is that real? Yeah, they're all real. Okay, so Polaris, the North Star, this one here, what this is showing is that these two stars orbit each other, and then together they co-orbit with this other star. So it's like Polaris B and these two stars orbit each other, and then these two orbit each other. And here it gets even more interesting, because if we go, no, we're going to Polaris already, so let's go a little closer and take a look at what the star looks like up close. It is a white supergiant, so it's big. Oh, there's the third one. That's the third companion. Okay, so we're going to change the exposure a little bit so it's easier to see. But you can see this star's got some plasma coming off of it called the solar wind. And the cool thing is we can actually set a camera to change the exposure, and you can really see the structure of this star. So it is a white star. Our sun is actually a white star as well, yellowish white. So, except this one's a lot bigger. 46 times the diameter of the sun, 4.5 times as heavy as the sun, and yeah, that's basically what it looks like. What these grainy little things you're seeing there, those are called convection cells. So as heat bubbles up from the surface of a star, it goes in these kind of columns. Heat travels up to the top, and then as that plasma cools down a bit, it sinks back down and makes these little convection cells. Okay, so we're going to make it brighter. So that's what it looks like. So here's the other cool thing. If we go to the solar system chart, okay, so now we can select where Polaris is, and if we zoom in a little bit, does it have planets? It doesn't look like it. Let's see, maybe the main sequence star has planets. So let's go in closer. So this is a different star completely. Doesn't look like any planets. The other way we can tell is if we leave the chart. There's a little thing up here. So there's Polaris A. Polaris A again. No planets. All right. I'm just going to make sure that we actually have... oh yeah, everything's turned on. So it's unlucky that Polaris, the North Star, doesn't have any planets, real or fake. But it is 3 stars orbiting together. These 2 stars orbit each other. And then as we move faster and faster, further away, we see the 3rd star, and these 2 orbit each other as well. All right. By the way, anybody who is watching, if you feel like asking me to, or telling me something you want to look at, we can do that. We can fly right out of the galaxy too, which is kind of cool, so we might do that. If you want to go see the black hole in the center of the galaxy, we'll do that too. But I'm going to start small and kind of work our way up. I'm actually going to go to one of my favorite stars called Vega. It is in, it's that bright blue star that you can see tonight, all summer actually, overhead. So we're going to go to Vega. A very different place in the sky. What you're seeing here, the 2 Magellanic Clouds, those are galaxies that orbit the Milky Way. They're only visible from the southern hemisphere. Okay, here's Vega. Now, this is cool because you see Vega kind of looks like a football, but here it doesn't, right? That's because Vega actually spins so quickly that it's got this football shape. It's oblong. Oops. So it's like one of the weirdest stars you'll ever find because it spins just so quickly. Now, the question is, does it have a planet that we can go visit? Oops. Let's see. Well, we're there. It's on its own. Okay, so let's go. Oh, it's just on its own. Okay, we're there. So it's on its own. No companion stars, no planets. I was hoping there'd be like a procedurally generated planet around Vega because that would be kind of cool, like the movie Contact, for all of you older astronomers who remember the movie Contact with Jodie Foster, where she actually goes to a planet around the star Vega. So I think we're going to have to go a little bit further. By the way, let's go take a look at the sun, just see where it is. And we're just going to center on it so you can see kind of where it is. It's somewhere out there. We can zoom in. Oh yeah, there it is. There's the sun. So we can zoom right in and see, hey, that's our sun. So we're pretty far away from the sun. We're going to go back to normal. Okay. Oh, look at that, a nebula. That is the Carina Nebula. We're going to go and we're going to just start flying through space and looking for something fun to dig into. So let's go faster and faster and faster. I'll actually take us right out of the center of the galaxy. There's a lot of stars in the Milky Way. I don't know if you know that, but I saw a report that it has over 1 trillion solar masses, which means the total mass of this galaxy is over 1 trillion suns, which is crazy. So we're going to go fly up above the Milky Way. Ooh, faster and faster and faster. And you can see the core there. Do you see all these little dots there? These little dots are not actually stars. These are special. They're called globular clusters. Globular clusters. So we're actually, why don't we go visit one of those? But this is our galaxy. This is the Milky Way. 120,000 light years across. All, well, several hundred billion stars. Lots more planets. Thought to be over 1 trillion planets in the Milky Way. And our Earth is in the Milky Way. The sun is just one of the stars that lives there. So let's go find a globular cluster. We're flying way faster than the speed of light. I don't know if you see that. 5.23 thousand, so 5,000 light years per second is how fast we're traveling. We are above the core of the galaxy, which is down there. Oh, and there's a good globular cluster. I clicked on a black hole. What do you know? All right, we'll go there. So here's our globular cluster. We're going to slow down as we approach it. A globular cluster is a collection of stars. A lot of them are thought to be remnants of ancient galaxies, like the cores of ancient proto-galaxies that all merged to form the Milky Way. They tend to be have a lot older stars inside, but just tons of them packed together. They really look nice if you take an image of them. So I'm actually going to snap a photo because I can take screenshots. There we go. And let's go inside this globular cluster. We're going to go in and just see what it would be like if we lived inside a cluster like this. How bright would the night sky be? We're going to go all the way in, and we're just going to pick a star. Slow down a little bit. That's a fine looking star. White main sequence star. That's a good place that might... Oh, look at that. It has 5 planets. You can see up here. I will tell you that it is not a real star. It might be a real star in the cluster, but in Space Engine, it's been procedurally generated. And I know that by the designation at the top, RSC is kind of the generated stars. So we're going to go closer and closer to the star. Did you lose it yet? There's so many of them here. I think we went right past it, actually. Yep, we did. This is the problem with Space Engine, is that you can fly right past things if you're not careful. So we're going to go closer. I'm actually just going to hit go to, and in 10 seconds, it's going to take us all the way to this star. All the way up close. Here we go. All right, so there we are. We are very close to this star now. We're going to have to go faster and faster, I think. What's going on? Oh, I know what I did. Okay. Whoops. Oh, geez, now I did it. Oh, look at that. I left the entire galaxy. Okay, let's just go there faster. This might rock your brain for a second. I'm going to switch off so that it doesn't blind anybody, but we're back into the globular cluster. Okay, and we're back to that star that I was aiming for. All right, let's slow down quite a bit. Okay, so we're going in closer. There we go. Look at this. So these are planets actually around this star. You can actually see them there. If we put on the orbits, you can see all the planets working their way around. And that's kind of cool. We can actually set time to go forward, and we can watch these planets actually orbiting this orange dwarf star that I seem to have come to. So let's take a look at the solar system this time. We're going to pause the time. We're going to take a look at the browser. Oh, wrong one. This one, the chart. Okay, so now, oh, this is interesting. So it's 2 stars, this orange dwarf star and this red dwarf star, which they're small, right? This star is less than half as heavy as the sun and half the size of the sun, basically, half the diameter. This other one is a little bit closer, but still smaller than the sun. And these two are orbiting each other. They're orbiting this. This is called their center of gravity, or barycenter. And all the planets are actually going around both stars, the barycenter. So if we go in and take a look, these are the planets. This is one of those planets. So it's cool that the information that Space Engine gives you is really neat. Like, this is a hot super Neptune. And, well, it's pretty hot. It's 346 degrees Celsius. It's got 7 moons, an atmosphere of hydrogen. So we want to find a planet where, or a moon maybe, where there might be some life. This one is warm, Oh, look at that. 123 degrees Celsius, but 21 degrees with the greenhouse effect. So it might actually be pretty nice there. It has 3 moons. It has an atmosphere of carbon dioxide. So it's a lot more like Mars. And let's go in a bit closer and take a look. So this is that planet, and it's super oceanic, which means this planet is covered entirely in water. Those are clouds above it, which is kind of cool. Its moons look pretty small. They're probably dwarf moons. Oh yeah, that's an asteroid. But again, we can go right up to this thing and see what it looks like. So that's one of this moon, one of the moons of this really crazy little planet. So let's go out and see some of the other moons. Having some scrolling troubles here. Let's go to the other one. Yeah, again, another asteroid. So this is one way to view things. Let's see some of these other planets here. That is an arid, cool subterra. So pretty cold. 1 degree, that's actually not bad. But again, an atmosphere of sulfur dioxide and carbon dioxide. Not very good. Not very nice. But it's got a pretty big moon. Mini Terra moon. So that moon is 1/5 the diameter of our moon. Sorry, 1/5 the mass of our moon and about 1/8 the diameter, which is kind of cool. Okay, so why don't we actually see? Oh, is this a good planet? Frigid, cold. So you're noticing that the planets actually get colder as they move away from the stars, right? So the closer you are to a star, the hotter it is, as expected. And so if you want to find a planet with life, you need to find one that is just in the right spot, what we call the habitable zone. Mini aquarium. I'm just looking for a good place to kind of to visit, basically. So let's go. So that's a cool looking moon. Cold, airless mini aquaria. Yeah, let's just go to that moon. All right, we're gonna go a little faster. It's gonna fly up really quick. So remember now, we are in a globular cluster around the Milky Way galaxy. On looking at a moon that is orbiting a gas giant. So look at this. This is all these stars. You can actually see the Milky Way behind it. You've got this big planet, or sorry, this moon orbiting this double star. I see one of them. And it's also, this is a moon of a big planet. So let's go down to the surface and see what it looks like. Now again, this is procedurally generated. This is not a real moon. But this is what this real moon might look like. So here we are on the surface of a moon orbiting this giant mini Jupiter planet, which is 11 times as heavy as the Earth and 3 times as wide as the Earth. But that's a gas planet. We've got these stars all over the sky. This is what the night sky would look like here. And this giant galaxy, our Milky Way, covering half the sky because it is above the Milky Way. It's kind of a neat scene. And I try to, if you want to kind of imagine what it's like to be a person there, we get a kind of a wider field of view. This is what it might look like if you were standing on this moon looking up. Like, isn't that cool? That's our galaxy. There's just stars everywhere. And there's this planet that we're just flying around. So let's take off. Go back to and take a look. This moon's got, it looks like we're inside this big kind of crevice here. It's a weird kind of structure. Maybe some aliens drove along there where there was some flowing water. Let's fly up a little bit higher. We're actually going to just leave. Sorry for the motion if it makes anybody a little dizzy. I'm going to try and move as slowly and as cautiously as I can instead of just going a little bit insane and just going all over the place. There it goes. So that's the moon that is orbiting the planet. There's the planet with all of its other moons that is orbiting the stars, which are flying around somewhere. As we go faster, there's the stars. And now we're still in this globular cluster. So let's go a little bit faster. And as we go faster and faster, we can see we start to actually leave the cluster behind us. This big clump of stars everywhere. And this is what we see from Earth. So the cool thing is that this is real. Like, you could imagine traveling on a spaceship to this globular cluster and finding stars that have planets. It's very likely that the stars in this cluster have planets. And every star that you see in the sky should have some. So we're still above the Milky Way. This is our Milky Way pretty much everywhere. It looks like the core is down here. So why don't we go and investigate the core. Now, in the core, there's a lot more stars. First of all, this is also a camera view, right? So we can make things a little bit more... Actually, you know what? It would be cooler. This down here is called our magnitude limit. That's basically the dimmest thing that you can see is 7 magnitudes. But if we increase that, it's going to let us see more and more and more and more things. More stars that are further away and therefore dimmer. So like there are actually tons and tons of stars in this galaxy, the Milky Way. So we leave the magnitude limit a little bit higher. It's going to tax the computer, but who cares? We're flying through the just billions and billions of stars in the Milky Way. And as we go faster and faster, we go through more and more of them. And we can pick any one of these and go and travel around, travel to it. And I think we will. We'll just pick a random one. We'll slow down a little bit. There's a nice looking one. Select that. It's a triple star system with 7 planets. Okay, so we're going to set the magnitude limit back down. Those stars are all there. It's just it was brightened. It's like having a better telescope or more sensitive vision, okay? So we're going to fly out to this triple star system, and I'll bring up the browser so you can see it's 2 stars, and then there'll be a 3rd star kind of orbiting them, I guess. I think that's the B star there, yeah. So it's 2 stars with a 3rd star orbiting them really far away. This is actually a common setup. 2/3 of all the stars in the known universe are doubles or triples, which means there's 2 stars orbiting each other or 3 stars orbiting each other. That's just how the universe is built. So our sun is actually kind of rare. Our sun is lonely. It's kind of on its own. Is that what life needs? Right? Does life need just one solo star? Or can these planets that are surrounding these double stars form life? So let's take a look at the structure of this system with our solar system chart. Okay, so we've got... Oh, that's interesting. So it's these 2 main stars, a 3rd star, and these 2 stars are close together, this big one. This is a white giant that is almost twice as big as the sun. And this white main sequence star, also almost twice as big as the sun. Those 2 stars are orbiting their center of mass, right here, A. They're orbiting each other. And then those 2 together are orbiting the center of mass of them and this other star, which is a white dwarf, strangely enough. They must be pretty far apart. And then the planets, all in here, whoops, all down here, these planets are all orbiting all 3 stars really far away. So I wouldn't expect that any of these planets have much in the way of life. We've got a frigid... Oh, there's supposed to be... Actually, there's supposed to be a bunch of planets, though, so maybe we've missed a few. So it looks like 2 planets here, but the system has, I think, 7 of them. So let's take a look here. An arid Aquaria, moon. Not a good place for life. I think it's fun to just try and find something that might have life. This planet, pretty cold, frigid arid Aquaria, which means basically frozen and wet. It's got a couple of really small moons. Oh, look at this. You can even see the rings. There's the rings of this, like, sub-Neptune that we see here. Okay, but there were supposed to be more planets. I think there were supposed to be like 7 of them. So where are all the planets? Well, if we go a little bit, let's go closer to this star. I'd be betting, yep, there they are. 1, 2, 3, 4, 5. The 5 of the planets are very close to this blue star, this white dwarf. And if you look at the temperatures, the closest planet has a temperature of 3,000 degrees, the second closest, 1,700, and so on. So they're all really, really hot. Not a great place to live. By the way, if anybody wants to see anything in particular, if you want to go to a black hole, if you want to go see a galaxy, if you want to see any object in the universe up close, let me know. Otherwise, you can do that in the chat. I'm just kind of scrolling around looking for planets that might have life and just exploring a few different planets. So let's go take a look at our solar system viewer again. And we'll go in a bit closer. Yeah, there we go. There's all the planets. So here's the star. This star is actually pretty small. If you look at the data in the upper left, this star is 15,000 kilometers across, which means it's only like the Earth is 12,000 kilometers across. So this star is basically a little bit bigger than the Earth, but it weighs more than the sun. So this is it's called a white dwarf. It's a really heavy, dense, compact star. Like a spoonful of that would probably weigh about 100 pounds. Like imagine a spoonful of that star, about 100 pounds. And so it's got these planets that actually, I think this planet is like bigger than the star. 1.24 diameter of Earth. That's in diameter of Sun. So 15,000 kilometers, 15.8, 15. Yeah, this planet is literally wider than the star that it's orbiting, but a lot lighter. So like these are very hot planets. Like this one, 3,000 degrees. Even this one, 1,000 degrees with 5 moons. This moon is 900 degrees because they're so close to that little white dwarf star. This one's interesting. Subterra, 500 degrees Celsius, and has 10 moons. Most of these are probably captured asteroids. Like if we go in and zoom in on this one. Yeah, there you go. It's an asteroid, 53 kilometers across. Not that exciting, not that interesting. We're going to go look for something else. So let's go and leave. So that's that star. Let's go look for something else. There's 2 of them orbiting each other. All right, now we're back flying amongst the universe. What else do we want to see? Let's keep going. Why don't we look for a red star? A red star, a red star. There it is. Whoa, too fast. Okay, let's go to this carbon star. That's interesting. All right, let's do it. Its mass is 6 times the mass of the sun. It has 7 planets. It's close to the... Oh, wow. It's close to the center. Oh, gosh, here we go. This is crazy. Is that a planet? Yeah, that's a planet. That's pretty close. Let's go to this planet. This is going to be funny. Because this planet is, like, literally you can see gas and stuff boiling off of this planet. This particular planet, yeah, that's 1,700 degrees Celsius. Oh, look, it's got a moon. It's got a few moons. But look at it. It's like, whoop, too fast. Slow down, slow down, slow down. So it's like literally boiling because the star is literally right next to it. Like, I just want to show you. We're going to go, let's go to this, that's the star. Ooh, select the planet, please. There we go. Let's go land on this planet so I can show you what the star looks like in the sky. We're going to fly right through the clouds. If it has clouds, it shouldn't have clouds. It does have an atmosphere, but yeah, it's pretty hot. That's the star. So we're pretty close. The planet is pretty hot, about 2,000 degrees Celsius. So basically like a big lava world. Literally the floor is lava. But if we look up, we can see the star literally right there. So this is a pretty inhospitable place. It does have clouds, which is probably not correct. But yeah, there's the star. We can lower the brightness a little bit so it doesn't blind us. But yeah, so that's pretty close. We're going to go a bit further away so it's safer. But yeah, that planet, terrible place to visit. Don't go there. Not that we have to worry about that, right? Okay. Let's go find a nebula. What's a good nebula? Any suggestions? Tell me the name of a nebula. I'm going to go flying around a bit more. See if we can find anything as we fly through the galaxy. We have shy chat people, but that's okay. Oh, hey, Jen says, hi Ryan, can we check out a black hole? I'm going to check out the black hole. We're going to go find the black hole at the center of the Milky Way. The one that actually is there, the real one. It's called Sagittarius A star. this one here. Thank you for asking. Oh, the Crab Nebula. Yeah, we'll do the Crab Nebula next. Okay, so we're going to this black hole in the center of the Milky Way. I'm just going to pull off it for a second. There's a reason for this. I don't want to. I actually hit the go-to a little too fast, and I want to actually, give it some intrigue as we go a little bit closer to this thing. I will show you the black hole, and then I will show you the Crab Nebula. So thank you for asking for those. So let's back it up. Okay, let's bring us back. So here we are. This is in the core of the Milky Way galaxy. We are literally very close to the center. We're 630 light years away from the black hole, which is in the very center here. So we're going to go in really close. Let's take a look as we start to move faster and not too fast. Ooh, you know what I did. There we go. Okay, here we go. So we're going to go in closer and closer. We see stars flying past us in all directions. We are traveling faster than the speed of light by a long shot. The distance that we're covering is incredible. And 30,000 light years from the Earth lies this clump of stars in the very center of the Milky Way. As we approach it, it's going to get brighter and brighter. There's a bunch of stars that are pulled right in, orbiting very close to the black hole. And over a period of years, astronomers have actually measured these stars flying around the black hole, and they can track those stars, and that actually helps us figure out how heavy the black hole is. So we're going in closer and closer, and we're going to slow down as we go in. This is the center of the Milky Way. This is what it looks like. Stars, giant stars, not just little ones. These are huge stars. Blue main sequence star, that's a big one. 180 times as heavy as the sun. That is incredibly gigantic. But we're still on this black hole. We're going to go in closer. We're going to slow down a bit more. Like I said, most of these stars are hundreds of times as heavy as the sun. But look at the mass of the black hole, 10 to the 6 m sun. So over 1 million times, 4 million times rather, as heavy as the sun. And here we go. You can't see the black hole yet. These are all stars. But we will see the black hole because this particular black hole in the center of the Milky Way is sucking up gas and dust so quickly that it's glowing. Now you can see it. The material that's falling into this black hole is heating up so hot, hotter than the surface of a star, that it can be seen in X-ray. It's firing off X-rays. And we're going to go in closer. We're only about 1,500 astronomical units. That's 1,500 times the distance between the Earth and the Sun. We're going to slow down as we go in closer. And now you're going to start to see the structure of this black hole. There it is. Let's go a little faster. There's big jets flying out of the black hole. And here it is. You can start to see the disk of stuff that's being sucked into this black hole called the accretion disk. It's rotating really, really quick. I'm just going to change our time speed here because I want to actually see this stuff rotating. This is what a black hole does. It's shooting out jets of gas and dust in directions that are perpendicular to its plane of rotation. I know it's a lot of fancy words. Don't worry about that. As we go in faster, we can see it spiraling around the gas and dust. We're still 300 times normal time speed, but as we go closer, the camera's going to adjust the brightness. We're going to get to higher and higher temperatures. Let's turn around so we're right along the plane of this black hole. This is called Sagittarius A star. We're going to slow down a little bit. We're actually going to slow time down a little bit. We still want to see it rotating. But as we go closer, we can change the exposure. We're going right in to the absolute core of this black hole. This black hole, 4 million times as heavy as the sun. There it is. This is it. This is a real black hole. We've got to lower the exposure so much because the material falling around it is so bright. It's glowing. It's so hot and so bright that we wouldn't be able to see it. You can see it moving as stuff falls into the black hole. You're seeing this little kind of ripple over top of it. That ripple is because the light from behind the black hole is literally being bent around it. This disk is flat. Stuff's not actually going over top of it. You can literally see behind the black hole because light is being bent over it. Let's go all the way in. Now, this is the cool thing about Space Engine is that we can go through this really extreme stuff. And this is it. This is a black hole that's absolutely enormous. Its diameter 0.17 astronomical units, so about, let's say 15, it's about a tenth. Yeah, okay, so about 15 million kilometers across. That's pretty crazy. This is a black hole. And so it's giving off lots of light. Now, not all black holes you can find them. Not all of them can be found. This one is called a supermassive black hole that resides in the center of our galaxy. These black holes are so large that they often are sucking up lots of gas and dust, and that heats it up and allows us to find them. But there are billions of black holes that are just out in space, out all around us in the sky. I'm going to go back to our normal, that's how bright it actually is, right? Our normal exposure. But just in the night sky, there are billions of black holes that we can't see because they're not sucking anything up. They're just kind of floating along. Those black holes tend to be a lot smaller, like a few kilometers across, because black holes, although they're so heavy, they're very, very dense, which means they're really compact. So unless one of them comes pretty close to you, you really don't have to worry about it too much. So this is the black hole in the center of the Milky Way. And let's go all the way out. Let's just go flying right out of the galaxy backwards from the black hole. We see the central core stars, the hottest, the biggest, the brightest stars in the galaxy, very close to the black hole as they slowly will get sucked up. What's the largest black hole? There was actually one discovered this week in the very early universe that is something like 4 billion times as heavy as the sun, which would be about 100 times as heavy as that one that we just looked at. Thanks for that question. So let's keep going. Let's go further out. We're going to go say goodbye to that black hole and see all the 400 billion stars in our Milky Way as we fly out faster and faster and faster, and we leave our galaxy. Most galaxies have a giant black hole in their core. We can see lots of other galaxies out there too. But I did say I would head to the Crab Nebula, so let's go do that. Thanks for that suggestion for the black hole, Jen. And Heated SC, we're going to go to the Crab Nebula. So thank you for suggesting. All right, let's center the Crab Nebula. So it's way over here. We're going in fast. The Crab Nebula is a supernova remnant, as it says up there, which means it was formed by the explosion of a star. It's pretty far out of our galaxy. Actually, the Crab Nebula is especially interesting because in the year, I think it was 1100 AD, some astronomers in China actually saw this star explode. Sorry, I'm going to go a bit closer. Let's go a bit faster. Okay, so we're back in the galaxy. There's the Crab Nebula, just in the center. We're not going to go too fast because we don't want to blow right by it, but it's pretty big. So about 1,000 years ago, a star exploded, and that's as a supernova. Like I said, astronomers in China at 1100, they saw it, and they wrote down, oh, hey, we saw this weird guest star in our sky. And they wrote down where it was. And 1,000 years later, today, we can look, not quite 1,000 years, but just shy of 1,000 years later, today we can look up and we see this nebula that's left over. It's still growing, it's still getting bigger, it's still expanding. Because this explosion is still happening. This 1,000-year-old explosion is still happening. But what's left, if we go all the way into the Crab Nebula, By the way, the nebula is glowing. It's basically made of hot gas and dust. Lots of heavy elements, things that like titanium, or even I'm not sure what else is made in supernovas, but some very heavy elements can only be made in supernovas because they're so high energy. So lots of elements going around. And the cool thing about this is that these elements will eventually collide with other clouds of gas and dust and go into forming new stars. I mean, the stuff on the Earth, the stuff that we're made of, the elements on the Earth, a lot of them came from ancient explosions of supernovas that collided with our cloud as it was forming the sun, and then the sun ended up having those heavy elements around it. So let's go in closer though. In the very center is a neutron star. So this is a really cool one to visit. A neutron star is kind of the step below a black hole in terms of craziness. It is very dense, very heavy. This neutron star weighs 1.5 times as much as the sun, but it's only, it's not very wide. It's only, it looks like, it's got a star around it. Let's go and see how wide this thing is. There it is, the Crab pulsar. Its diameter is only 20 kilometers. Whoops, we went right by it. So imagine now, 1.5 times the weight of the sun, the whole sun, which is, 1 million times as big as the Earth, and you cram that into this little star that's only 20 kilometers across. That's a neutron star. A spoonful of that would weigh as much as a mountain. And we're going in close. Here we go. Pulsars are basically rotating neutron stars. So this star, this neutron star that's only 20 kilometers, is actually spinning really fast. And if you think about it, it makes sense. If you take something that's really big, that's spinning kind of slow, and you cram it, make it smaller, it's going to spin faster. It's just like a figure skater with their arms out. As they start to spin, they pull their arms in, their center of mass goes closer to the center, and they spin faster. So these neutron stars can spin like thousands of times per second, and I flew right past it again. So I'm not going to do that this time. Does it tell us how? It doesn't. Oh, rotation period. Okay, so here you go. This star spins every 3/100ths of a second. So about, let's see, 300 times a second it spins. This is real. This is not a generated object. This is a real thing. And we're going in close. Let's take a look. It's only 20 kilometers wide. Oh, I did it again. I flew right past it. Slow down, Ryan. See, and this is the problem. When something's really small like this, very compact, only 20 kilometers across, we have to make sure that we slow down slower and slower and slower to get close enough to actually see what it looks like. However, I'm going to just cheat and just hit my go-to button so that in 10 seconds we'll get there a little bit faster. I suppose I should have done that the first time, but here we are. So look at this thing. It's, okay, so time, let's go to actual, okay, so this is real time. And these jets of magnetic energy are flying out of this thing. It's really bright, but we can see it actually spinning super, super fast. Don't worry, it's not too dangerous. We're actually going to slow down time so that we can kind of get a sense of this. Like, we're going at 1/100th of a second for every second that we experience. And we got to lower the exposure even more. Like, the thing about pulsars is that they have such a huge amount of magnetic energy flying around them. This is not unlike the black hole. It's just it's spinning much faster. There we go. The thing about neutron stars too is that they're not necessarily spinning faster than the black hole. It's just a black hole has this event horizon that extends out of it that kind of you can't see into anyway. So you couldn't really see how fast a black hole's spinning. But let's go in. In space engine, neutron stars tend to look just like black holes, except they're white instead of dark. So let's lower the exposure even more, and you can kind of see the neutron star itself. This is only 20 kilometers wide. This is a star made entirely of neutrons, Like I said, one spoonful of this thing would weigh as much as a mountain, which is insane. And this all came from a star that was bigger than the sun, usually about 4 or 5 times as heavy as the sun, but bigger than the sun when it exploded as a supernova. And that object, that neutron star, pretty bright, is in the center of the Crab Nebula, this giant explosion that's been going for 1,000 years. And we can actually see the Crab Nebula from Earth. So let's go. We're just about at the top of the hour, so we're almost done, but we're going to go and just look where we're going to go to the Earth, I guess, since I pressed the wrong key. But we're going to take a 30-second trip all the way over to the Earth. If anybody does have any other questions or suggestions for things to look at next time around, I am going to try and do this once a week where we just explore some different things in the universe. Unfortunately, we didn't find a planet with life, but there is a way to find them, to kind of search for a place that does have life. And you know, that's not real necessarily. Like if we find a planet with life other than Earth, it's a procedurally generated planet. So the planets that aren't real in Space Engine, some of them do have life on them, which is kind of cool. Okay, so let's look at the Crab Nebula now. We're back at the Earth, and we're going to center on the Crab Nebula. So it's right over here in the sky. And if we zoom in on it, that's what it looks like from Earth. This little fuzzy patch. So we were there. We were inside the Crab Nebula. We can zoom in even further. There's that pulsar, I think, right in the middle. Is this the Crab pulsar? I don't know. Anyway, that was a galaxy in the background there. What is this program called again? This is called Space Engine. Space Engine. I think it's only like $20. And it's a lot of fun. Some of the things you can do with it that I like to do, of course, because I'm a planetarium guy, I actually change it to a fisheye perspective, and I don't know what I did there, but oh boy. Yeah, I've done it this time. Oh, the magnitude limit's really high. Oh, I know what I did. Well, I've made something bad happen anyway, but either way, there we go. Okay, that's better. Yeah, so it's called Space Engine. I'll type it in the chat. Space Engine. There we go. It's made by one guy, which is kind of crazy. He's been working on it for a long time. It's not officially released yet, but it's on its way. There's the Earth. Let's fix the field of view. And there we go. We ended up back where we started, back to lovely planet Earth as we toured through the universe. Awesome. That was pretty cool. And I think we're going to finish there. I know this is a little bit weird. I don't stream often, but I love to talk to people. So thank you for at least typing some things in the chat, for the shout-outs, the hellos, naming a nebula. Thank you for that, asking about black holes. I just want to talk about the cool things that everybody's interested in. So next week, we'll do the same thing. We'll do another hour. We'll play around in Space Engine. I'm going to post this to YouTube, so we'll be able to actually find it. And then we'll have some more fun while we're all stuck, slowly working our way out of quarantine here in Canada. So until, yeah, thanks Jen, saying so happy you're back. I'm glad to be back too. Hopefully we all get outside soon, but enjoy the nice weather. If you get outside tonight, go and see Jupiter and Saturn if you feel like staying up late. But otherwise, stay safe, stay healthy, and we'll see you next time. Have a great one. Goodbye.